Hello all. This mini lecture is on the ECG, on the electrocardiogram. An electrocardiogram is a measurement of an electrical current that's generated by cardiac action potentials. So think of all those gap junctions, and this electrical current is swooshing through the heart. And if you were able to record those currents that are flowing from the atria down to the ventricle and depolarizing them, and you could make a recording of that, that's the ECG. That's the electrocardiogram, sometimes called EKG because that would be in German. And so we started out calling it EKGs and then decided that we could say it in English. We know that the mechanical events are going to lag behind the electrical events. So when we look at an electrocardiogram, we're thinking, okay, this is what's happening electrically, and then we can assume what happened mechanically after that. Some items here on ECG or EKG, I spelled it that way on this slide. It's going to measure the sum of all electrical activity in the heart. That's good. What else? It's not a recording of any one cell. What do you mean? Well, it's not a direct recording of an action potential. It's not like, oh, look, it's depolarizing. Oh, look, it's repolarizing, and therefore I have my curve like you've looked at before. It's not like that. It just measures differences in potential within the heart. So from place A to place B, it's going to be depolarizing in one and not in the other, or repolarizing in one and not in the other, and it's going to show these different curves. Okay? It's not any one single cell that's getting recorded. Depolarization and repolarization are both seen as a curve that rises, an uphill curve. So up to now, what goes up was a depolarization, what comes down is repolarization. You have to shift that thinking when you look at an ECG. It's not going to look that way. How is it going to look? Well, this is a tracing of 3 waves of an ECG. So first of all, you would have a deflection like this, and we're going to call that a P wave. A P wave, a deflection, and then sort of a down, up, down, and back up again. That's a much larger one. And because it has both down and up and down again, we're going to call it a complex, because more than one thing is happening. So that's the QRS complex. And then this last blip here is the T wave. Okay, so those are really good names for it, things that are easy to remember. P, QRS, and T. And then nothing's going to happen for a while, nothing's going to happen for a while, and then we start again. P, QRS, and T. What does it mean? So let's go to the writing here. The P wave is the time in which the atria are depolarizing. So that first wave at the base of the heart is starting out. That's going to show a difference of electrical activity in part A to part B of the heart, so it's going to show that wave. The QRS complex is ventricular depolarization. So now it's the ventricle that's depolarizing. And it's a much bigger wave, as you see, because its mass is larger. And the last one, the T wave here, is the repolarization of the ventricle. Notice how you're not expecting something to go down. It's still going up because it's a change from one location in relation to another location. So in that section there, the ventricle is repolarizing and going back to its original state. So the question that usually comes up right away is, shouldn't I have 4? It's the atria depolarizes and then repolarizes, and the ventricle depolarizes and then repolarizes, which means I should have 4 of these. Where is the section of the atrial repolarization? Well, that would have happened here at about the same time that QRS complex is happening. Therefore, it's not visible. You don't see it as 2 different blips. It would be hiding. So you only see the 3. The terminology is when you speak of a wave, it's going to appear as a deflection above or below that baseline. So you have the, the P wave and the T wave. Don't worry about the U wave here. And then again, a complex when it's more than one. And then what is a segment? So a segment is the section of the baseline between those two. So notice here, the segment from there to there is referring to the PR segment. And then when this isn't moving, that is also at the baseline between two waves, that is also a segment. Okay, let's follow along and see what happens if you could take it one step at a time. Let's look at those events. Here we are depolarizing in the SA node, remember? So the SA node is going to fire, and the first thing it does is send these action potentials over to the other atria, but it's still sort of limited in this area. So you would have the beginning of a little deflection here of a P wave, because we mean atrial depolarization. Then we continue along, and now notice that in purple, all of it, both atria are depolarized. So we would then see that P wave completed. All of it had depolarized. You brought electrical activity to this area, and the outcome of that was that it contracted. So this would be electrical, and then this would be, I'm going to put an M here for mechanical. What's happening mechanically is that, look at the timing here, that my atria would contract after that electrical activity had been delivered. Okay, so on this graph we're plotting both of those. So we continue on. Now this is coming down, the action potential is coming down the bundle branches, the bundle of His and the bundle branches. So that would signify the beginning of that sort of Q wave. It's a Q wave that's going to be part of the QRS complex. So let's see as it develops. That's the little first blip, the first wave, followed by an R wave, because now it's a deflection again as it starts to come up the ventricle. And then an S wave down here where it's pretty much now finished depolarizing the ventricle. So this entire QRS together, those three waves, we call a complex. So depolarizations have happened, contractions happened, but now we must repolarize. And that's what you're going to see next. The ventricles, mechanically, I'm going to put the M there again, mechanically the ventricles are going to contract once that QRS has delivered its action potentials. Now where exactly this contraction begins is impossible to know. This is happening too quickly. So it's impossible to know at exactly what point it begins to contract, but we know that it will continue to contract quite a bit beyond the electrical event. Next is the repolarization, and in these diagrams it's been indicated in red instead of purple. So it's going back to its resting potential, and that is when you see a difference again in charge. So it's going to show a deflection, a new wave, which is the T wave, indicating that ventricular repolarization, And then it's complete. So all the electrical events have occurred, and you would begin again with the new depolarization of the atria. So this is going to travel along a little bit, and then you're going to get another P, and then the other QRS, and then the other T. And that's where we're going to stop. Thanks for listening.